Right, we were on the following night, and I first of all decided to measure the current being drawn by that capacitor to see if it was short circuit. At first it wasn't, right, but then soon afterwards, when I was doing some voltage tests across the resistor, which is resistor 81 there, that thing started bubbling up, so that's getting warm, that is getting hot. Right. I can't decide still whether that resistor is high or whether the capacitor was leaky in the first place. It probably was the capacitor, but I want to check that resistor anyway. And also because that capacitor's gone leaky, or going virtually short circuit, that means that resistor 79 may well have suffered. So I'll need to find that as well. Well, removing that resistor for testing turned out to be a Rishi Sunak success. God, look at that. Rishi Sunak success right there. Honestly, it's so cramped in here. Yeah, so I'll have to replace that anyway. Right, but that resistor needs... God, I'm getting component names mixed up now. That capacitor will need testing. And also, that capacitor is going to be replaced anyway. After a day of not much luck, I think I'm beginning to find the fault. There was one of the fault, which was a 30FL1 valve, which was going intermittently short circuit whenever you switched. Intermittently short circuit between the heater and the cathode. Whenever you switched it on, you could see some sparking inside the valve for the first 10 or 15 seconds or so, and you could intermittently hear like sparking. But anyway, so I've changed that, not without frustration though, because one of the replacements I've got had an open circuit heater, so that meant no filament. But, and I really should have looked at this earlier, that, yeah, you can probably tell that that is not healthy. So let me start again. That capacitor there with the surface like a teenager's face is the boost capacitor. Right, so that's a boost reservoir capacitor. It's part of this. It's that one there, capacitor 127. I think it's actually half of a double boost capacitor. I think that capacitor 128 does that as well, and in fact I think maybe that might be a decoupler. But anyway, capacitor 127, that is connected to the 205 volt HT line. Americans call it B plus on one side, and then it's connected to the boost. It's way too late for my brain. It's connected to this boosted HT line on the other. This acts as a power supply pretty much. Capacitor 127 is a reservoir capacitor, so it stores charge, right, for this circuit to use, because it's an AC circuit pretty much. So it needs that, and it's supposed to boost it up to 644 volts. We're actually only boosting it up to 308. Now that is, so start again, that is a wax paper type capacitor. There's another which is a black hunt, which is tucked right behind it. You can probably just see it just down there. But that is a wax paper type capacitor. And so that means that that is going to be leaky, so it's going to be passing crap on both sides pretty much. It's going to be passing some of the stuff that it gets from here back there, but mainly a lot of the stuff. So because it's passing it through rather than keeping it on both sides, rather than keeping the relevant voltages on both sides, we're getting a voltage loss here. And that would actually make sense, because if we're getting a voltage loss here going through there, then we're getting a voltage loss from this side going through here. So there's leakage from both sides going through it. So if there's leakage from here going through there, then that's going to bring this 205 volt rail down. That feeds the rest of the set. So this is going to be a big fault, and because of the time, I'm not going to replace that tonight. I'm not going to be able to. I don't have the time because I've got to be up in the morning. Let me switch it off. I just want to feel it. Ooh. Oh, ow, ow. Ow. Yeah, that guy's getting hot. I mean, part of that might be from this line output valve, but even if it was just the line output valve heating it up, that would only get warm. That guy is getting hot. Ow. Yeah, he's getting burning hot. That needs replacing. That has to be replaced. So that is a priority for tomorrow. We don't go any further without replacing that and the Hunts, the black one, while we're at it. Following day, and I've just grabbed a quick half hour to have a look at this, and yeah, that thing, that wax capacitor has got so hot it's actually started melting the Hunt capacitor next to it. See that gap there? See where it's split? See how it's all uneven? Yeah, that thing, both of them really need to come out. That's the, right, so that's the 0.25 one. So that must be the other one, the 0.35 or whatever odd value it gave us. Yeah, 0.25 and 0.35. So that one, which is the wax one, which is the one that's getting hot, will need to be replaced with a 0.33, and that one, which is the black melted one, that one will need to be replaced by a 0.47, because those are both of the modern equivalents. Well, it's a couple of days later, and I've separated the tube from the chassis. So yeah, you have to remove it. There's no way that the designers allowed you to replace some of these capacitors with the tube in. So That one needs replacing. But both of those need replacing down there. That one looks very unhealthy. That needs replacing. Those need replacing. And then, if I recall correctly, when I've got the tube back in, I should be able to replace these fairly easily. Right. So yeah, is this a capacitor? No, that's an inductor of some sort. That's a choke. Right. Oh, and we've got one of these. Got one of the red and black and yellow ones as well. Fantastic. One of these Plessy capacitors. Fan-dabby-dozy. Just testing that capacitor, and I've got to record this. 12 ohm ESR, 25% voltage loss. So yeah, that is definitely leaky. Oh, and I think it said also about 0.38. Yeah. Well, earlier that said 0.38 microfarads. Now it's saying, or 38 microfarads. Sorry, it's now saying 15. So that thing is like a swinging voter. It can't make up its mind. Anyway, my conclusion is that voltage loss is now at 17%. Conclusion is that thing has got to go. Just testing this capacitor for the fun of it, and it thinks it's a 27 ohm resistor. Okay, I think we can say that that one's leaky. That one is definitely on the slide. That one needs to go. That one was here, which I think might be the sound output transformer. I'm not sure. I will have a look in a bit, but I'm still in the middle of getting all these changed now. Done these. As I said, I've left these though because I can access these when the tube's back in, so I can then start to continue fixing when I find a fault. That is meant to be a 0.1 microfarad, 44 microfarads, 32% voltage loss. 32%. You couldn't make that up, could you? I'm at the stage now where I am replacing the last of the capacitors that have to be done while the tube is out, and these are almost always bad. Always go open circuit, as it said a moment or two ago, just before starting to film this. I'd made sure that these clips were on properly so that could pick it up, and they are on properly. They're not touching any dirty parts of the pins on the capacitor. Yeah, there's nothing with that electrolytic capacitor at all. There's these Plessy capacitors that are red and black and often come with a yellow sticker around it that now usually peels off with ease. These are no good. These are absolutely no good. These are pretty much the Rishi Sunak of capacitors. They're awful. Yeah. It's a pattern that I've noticed, and they only seem to be in TV sets from around 1960, 61, 62 as far as I've seen them. I've not seen them in mid-60s sets, and I've not seen them in mid or even late 50s sets. Well, after all that, this is the result. Okay, we are still... There's still a load of stuff to go through. I don't know why it's doing this twitching. The line oscillator still can't get up to speed. That is way too low. In fact, why is the line oscillator affecting the frame output? There's probably going to be some leakage there as well. Sorry, my camera work. I still need to get into the habit of looking through the viewfinder so that you see what I'm seeing. I'm sorry about that, guys. Yeah. So why? See, that is much better. That is light years better than what we had. I still don't understand though why adjusting the vertical, why there's some interaction between the line and frame stages. I'm adjusting the horizontal oscillator. See, I don't know if you can hear that, but when the picture twitches there, and I'm not adjusting it anymore, you can kind of hear that warble a little bit. But the picture is twitching vertically, so that's the frame stage. Unless we've got some leakage somewhere in the sync separator. Well, this has two sync separators actually. One traditional line and frame sync separator, and then it's got a special one for the flywheel diodes, which help stabilize the width of the picture slipping side to side. Murphy madness. Trying to adjust the height, and the height does barely anything. Unless that's meant to be the height. No, the lines are way too far apart, even for 405. That line width there, the height is way too... Yeah, I've turned the height way too high. You can practically get your fingers through that. Those lines are way too far apart. So let's turn that down. Yeah, so we've still got issues, but that is a huge improvement. That's a huge improvement. So yeah, the boost capacitor that was there, or both boost capacitors that were there that I've now replaced with yellow things, they were no good. These two yellow things down here, those are the replacements. The originals were absolutely no good at all. So yeah, we've still got some faults, but we're getting there. So next chapter, I think I would still want to replace these capacitors under here. Let me switch this light on. These capacitors down here, because they are in the line stage, which is not working properly, not reaching the right frequency. I was just doing some voltage checks, and 33 volts is still 18 volts. I can't remember what it was from a few days ago. 20 volts is still only 3 volts, I remember that. The capacitor 68 has already been changed, and it's still the same, so that means either that resistor or that resistor are suspect. I would say that one is the chief suspect of the two. Capacitor 69 has not been changed, and that's one of those wax paper types, so that will need to be changed soon. But yeah, we need to be looking here, I think. Resistor 81. I've already had a look, and it is elsewhere in the manual, and it is this one here. And that looks yeah. In fact, is that a crack I can see in it? Oh no, it just looks like some of the black stuff. I thought that see if I can add a circle on it in editing. I thought that was a crack. Okay, I goofed up a bit. It's resistor 81 that we're looking for, which is actually not that one. So resistor 81. Right, just zoom out a bit. Right, resistor 81. 81, where is it on this grid reference? B1. So, right, okay, B1, it's there, which is actually just up here. I think that's, yeah, it's, right, so I've already changed that. Or could it actually be that one? It said 180. No, that's blue, grey, yellow, then silver tolerance. Okay, it's not that one. Yeah, it's got to be that one. That is 150. That's the one that, remember, that's the one that I didn't have in stock for replacing, so I've made that. Okay. So could it be the other resistor that's gone open circuit then? Could it be that one? Trying to work this out, and I'm not the most intelligent of people. Resistor 7933. Resistor 79, it's not on that page. There it is, D2, is that resistors actually? Yeah, D2. Right, so it's on this side, and it's there, I believe. Right, so that would be around here. It's going to be that orange one, because it was 33k. I need to test what that orange one is like. Actually, I would say that capacitor is the suspect. Look, it's, see if I can zoom in. It's, yeah. See that? That is fresh. I've just this second had this set on. That should, it's getting warm to do that. Might be because of its close proximity to the valve, but it shouldn't do that. It should not do that. That is that one there. Yep. So I would now change my prime suspect from that orange resistor, 33k resistor, to this. Actually, because if that is not driving that properly, then I don't think that the voltage at pin 7 would be high enough anyway. So it may well, so that capacitor may well be drawing current through the valve. In fact, no, that capacitor can't, sorry, the wax that you just saw here can't have been caused by that valve, because if it was, you'd see melting there, and as far as I can see, there is none. So yeah, this capacitor's going internally leaky. So it's leaking. So it's no longer being a capacitor, it's starting to turn into a resistor, pretty much. I think we have our answer. It's 28 microfarads instead of 0.1. That's more like it. That is pretty much bang on. 34 volts. 33 volts on pin 6. In fact, no, we're seeing that on pin 7. Right, okay. 34 volts on pin 7 when it's supposed to be 20. So what does pin 6 measure then? Right, for now we're only getting 15 as opposed to 18 there. I did swap the valves over while you weren't watching, or rather when I was shooting. Let me swap them back. Let's do this, let's switch that off. Remember, these, if you're American, remember that our televisions are series heated for their tubes. That way. Oh yep. I know I want to populate that one, don't I, first? So I'll need to use my real eyes for this, rather than this expensive Panasonic fake eye that I am holding in my hand. Right. And that way. It'd help if I've got it in the right, there we are, in the right place. No point trying to plug it into a metal chassis, is there? What wattage? 90, 95, 98, okay. It's warming up. And we're still only getting... In fact, there, we're getting less than we were before. We're only getting 6 now. Okay. What's going on here? Is that one open? Yes, it must be, unless... No, there's no cathode resistor or capacitor. Is that open then? So resistor 77, 150k. We had a raster a few minutes ago. Let me switch that off. Whoop. Notice how, I don't know if you can see it there, but when the picture is dying away, it suddenly goes back to a frame, to a full frame. Okay, so I mean, is that resistor, is that valve shot? Only one of these two. Well, I wiggled those two about, and up it came. I know it's a circle, it's because I've got the scan coils pulled back at the part of the chassis so I can work on it. Okay. So I guess that's just got dirty pins on the socket. That resistor 77 has risen up to 250k. Okay, that is way out of tolerance. No wonder we've got such a low voltage there. Okay, after changing that resistor, we've got 25 volts at the anode now. It still should be 33. The TV, I don't know, might be happy with that. It might actually be measuring that. My multimeter might be measuring that. It says 33 volts there, but we should be okay. If I adjust the vertical hold, which one's vertical hold? That one. Yeah. That moves slightly. Yeah, it seems to be measuring the. This seems to be measuring that rather than. It seems to be measuring that rather than that. Okay. Still, we are getting better. So yeah, I'm beginning to look at these three resistors. That one, 152, 153 and 157. Maybe I should look at 154, but I'm going to look at these three first. 152, 470k, that's gone up in value by nearly 50%. So 690k. No wonder the line oscillator can't lock. I want to check that one still, and that one. In fact, I was reading something about that one. This one, 68k, is the modified version of the circuit. This still has the original, which is that one, which is 100. Was supposed to be 180k, but the middle band has burnt off really. So yeah, I'm going to modify it as well. An hour and a half I have spent just replacing those two resistors, because this I really don't think is a very good design. It's not a good design, but I can't think of anything else that they could have done. But yeah, because as you can see from that burn mark on the wire, it's so hard to get your soldering iron in there to replace both of them, and to make sure that the other components connected to the same pins on the valve, same valve pins, are staying connected as well. It's really hard. I do not wish this on my own worst enemy. I wouldn't even wish it on Boris Johnson. Also, one of the valve pins snapped when I was trying to remove one of the resistors, so I had to replace that. And also the original wire, which was here, the original wire, the sort of cotton, I'm not really sure what material it was actually, but the material on the outside of it just fell off straight away as soon as I just tapped it a little with my soldering iron. So that was exposing the metal wire inside, so I've replaced That's probably a little bit too long, but okay, right, so that resistor and that resistor. Now, that red, yellow, silver, that is, I thought I already had this ready. That is that resistor there, and that one is that 68k one there. Or is, well, I know it's not 68k, that one's 180k, but this is an early version of this model. 68, it was a modification to reduce, to change this for a 68k so that you got more stable picture in the line oscillator, so it wasn't so prone to slip sideways and that sort of thing, for the picture to slip sideways. But yeah, okay, I think after I've got both of those replaced, and that one, well, that one tested first. If it measures out of whack, then I'll replace it. I'm going to replace that one anyway. Once I've done both of those, I'm going to test it just to make sure I've not made any mistakes. If I have, I'll correct it. Then I'll have a little break of about half an hour because I really need it. Yep, that 221 is out of tolerance. It's a silver band, so that's what, 20%, I think, 20% tolerance, or variance rather. So 220 plus, so 10% of 220 is 22, so that's 220, 10% is 222, times that by 2, that's 44. 220 plus 44 is 264. 264k, and it's 295. Okay. And while I'm looking for it, I got my maths slightly confused earlier. Silver is 10%, so that then would make it 644, the upper tolerance. Sorry, no, I was talking out my arse. 220. 10% of that is 22. So that's 264, not 664, or 244. Yeah, you can tell how tired I am. And it's only 25 past 5. So I'm spending all of my energy, mental energy, getting that sorted. See that 180k? That has gone up to 290. Right, those two resistors replaced. Replaced the, what was supposed to be the 180 kiloohm 180k with a 68. Let's see if this goes bang. Probably will. No, well, that's a good sign. Hang on, this is not plugged in properly. Right. £108 watts, 102, 100. I'm really looking for anything under here, in case anything decides to go. Right, well, the line oscillator has started. I can vaguely hear it. Nope, there's nothing. Nothing at all. Right, what have I done wrong then? Those two wires, you see there? That was shorting to that valve. And as you can hear, we have line whistle. And now it goes high. And we have the opposite problem, it doesn't go low. But at least we've made some progress. Hally bloody looyah. Following day, and you can see we're starting to get something there. That is supposed to be test card C. I've tried it. This is on VHF channel 1. Sorry, it will be a circular screen because I've got the chassis, including the scan coils, pulled back. This is on VHF band 1. I don't know exactly what frequency, but VHF band 1. I've tried it on VHF band 3, including changing the channel on the Aurora, which is a 405 line converter and RF modulator, and there's nothing. So we have got tuner faults, I think. We have got tuner faults. My most favourite kind of fault. Whoop-de-doo! Whoop-de-doo da. Right, this is loose. This is the can, or part of the can, for the tuner. That was already loose. Someone's been in here before, and as we've now got this fault, and tuner faults are nasty, I bet that whatever fault is in here is what took the TV out of service in the first place. It does look kind of grotty in there. Now when I've connected this speaker up again, we get some sort of sound whenever I adjust the volume, but whenever I change the channel, that should pop, and it doesn't. So a little bit of signal is getting through here. You can see the top of test card C. Very little signal is getting through though, and there's absolutely nothing getting through to there. I've whacked the volume up to maximum. We have no tone whatsoever. I can't decide whether that is down to the signal just being so weak that it's not getting through to the speaker, but it is to the vision circuits just, or whether we've got an extra fault with the sound system. Probably the latter. Right, so now we need to go from the tuner back. So from the tuner, vision and sound stages, everything. We know that the time bases are working. Right, but I know that a lot of engineers say that it's starting to drift. I know a lot of engineers say that the time bases, like the line and the frame stage, are the hardest bit. I actually find them to be the easiest. It's usually this bit, the signal stage, that's the hardest. Also, I want to investigate what these do, because I know that some of the vision signal goes through this lot. I want to investigate what these capacitors from earlier do. I know that that black one is part of the line sync circuit. It's not what we're looking for to cure this, but I want to remind myself of what that wax capacitor and what that electrolytic there, that electrolytic capacitor, I want to remind myself of what they do. Also, of course, check the valves by substitution. Try cleaning out the contact pins from them, because they're a haven for coal dust and other stuff to get into. Yeah, unfortunately, unlike Shango, I can't think, I've never actually injected video and audio directly into a TV circuit before. I suppose I could always try for the first time, but I just want to see if it's going to be an easy fix for these. That makes wiggling the 30C1, which I think is the frequency changer. That does not make much of a difference. I'm going to have to be a bit careful with my fingers here. And neither does the wiggling the RF amplifier, a 30L15 valve. Not much difference, okay. Right, I've changed the valves over, and not much difference. We're slowly, very, 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 very slowly getting better. Let me see if I can adjust the frame hold or the height. So you see, there's a discernible test card there. I just can't get the frame stage to lock on properly. It seems to be running at twice its speed or something. So twice speed or half speed, something like that. Yeah, that's also, I can't get the sound to work when it's on this channel. When I leave the channel on the TV but change a channel up on here, we then start to get sound but no picture. I've tried changing the tuner valves, especially the RF amp. That's done something. I want to try changing again the mixer oscillator. So yeah, I think, however, I mean, I might as well try that, but I think we've still got problems within the tuner. But we're slowly getting better. Watch this. Still got picture. Right, so that valve socket is very, 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 very dicky. Probably the effect of my body's capacitance on it, that. This is where you really need some of this stuff. Servicol. VCF80, which is equivalent to a 30C1. Sorry, I know the camera work is bad, I know. Has this made an improvement? Probably not. I'll probably need to open the tuner up properly and clean some of the contacts in it using the same stuff, using this stuff. And now there's nothing at all. Oh, we should be getting something because can hear the line stage whistling. Nothing there. How about I adjust the brightness? Square root of diddly squat. What's going on with this set? I can hear the line stage finally starting. Hear that buzzing? But we have nothing on the TV, nothing on the screen. Oh, there we are. That was very slow to start. Now we have when they took the valve out just to clean the pins, what's gone on? Definitely a 1 step forward, 2 steps back kind of set. That's back. Right. It just suddenly started working again. That's also back, but now as you can hear we've got tone mixed in with buzzing. Just taking some measurements here, voltage measurements, and all the voltages here on the 30C1, which is the RF mixer and oscillator, the frequency changer, they're all okay, but here the voltages are much lower, and we know it's not the valve because we've replaced it 2 or 3 times, and it's, yeah. So I've decided to measure, because the HT, instead of going into the anode as on most valves, on tuner valves, for some reason I can't remember, it goes into the control grid, the screen grid. And I've measured across here that 86 volts is actually 36. That anode one is about 100, 103. That one's low as well. I can't remember what it was, but it was low. But yeah, it goes in here. So that 86 volts was about 36. The 4.7k resistor, which is that guy tucked right behind there, I thought that that one would be open or gone high because I recognise that type of resistor. I recognise the housing, they usually do, but that one seems okay. It then, oh no, sorry, it's not that one. Let me start again. It's that one. That one had gone high, or I thought it had gone high. It actually hasn't, so it's okay because the voltage is about the same on both sides. So then that leads on to that resistor through this tubing here, and this one I'm certain has gone high, because when I connect on that side, it's only, it did measure 33 volts a few minutes ago, it's now 27, call that 30, but let me just unhook that, and this is going to be really difficult. When I measure it on that side, it goes up to 159. So that line is measured there, pin 2, through that 4.7k, through that 56k, which is that one that I'm measuring, and then through this 1k resistor, and it becomes 205 volts, or rather it actually goes the other way. It's 205 volts. So 1k resistor, I was not surprised it goes down to 158, 159 odd. But then you should not be getting that kind of voltage drop off through that resistor. That resistor has got to be open. That is meant to be a 56k resistor. It's almost doubled in value. So yeah, that guy needs to come out. Cracking on with the Murphy Madness, pin 8 of this, which is the part of the automatic gain control. Pin 8 is measuring 58 volts, and pin 6 was actually measuring plus 20 rather than minus 14. So it was measuring 20 volts rather than minus 14. Right, we have issues here. So I've got a spare 6/30L2 or whatever it is. I'm going to try that in a minute, but I also just want to test, because just to help in diagnosing, I'm turning American, diagnosing the cathode of the common IF amp is also fed from there as well, which feeds into this voltage, which is low. That's also low, so it could well be a faulty valve or something down here. But also, just to eliminate this, I just want to check this as well, just to eliminate any problems with the supply coming in here, because that 1.2 megaohm resistor and that 100k also could be suspect. So yeah, so that is pin 1 of valve 3, and it should measure 5.7 volts with signal, 7.3 without. So let's check what that says. That measured 21 a moment ago, but now it's dropping down to 16. We are way too high there, so that means then that this valve could be suspect. I get the feeling I'm beginning to get lost in all this. Obviously, when I shouldn't be, but I get a feeling like I'm going down a rabbit hole here. But let me just check. Pin 7 and pin 8, they're both supposed to be the same. 203 volts with signal, 187 without. So let's try that. So that's... Right, yeah, this thing is really mucky. So pin... No, sorry, let me just try and see with my own eyes here, hang on. Let me just try and see with these. 987, I think I see it. Pin 7. There. Right, well, that's okay, so 198 volts. That's roughly where it should be. So I don't think then that that valve is faulty. Let me just check pin 8, that's supposed to be the same. Pin 8. There. Yeah, exactly the same. Okay, right, so our issues are... Don't think it's that resistor because it's low on both sides of the resistor, so resistor 37 I think we can eliminate. So we either, and I don't think it's going to be anything in the cathode circuit here, so C39, R32, R33, R34, and tapping off over there. I think that's all going to be okay. Right, but, it may well be okay because, in fact no, the voltage is high there and it's low down here. Right, okay. So in that case then we do need to look around here. High here, low down there. Resistor 32 is, resistor 37 is very suspect. 82k, where are you? Resistor 37, 37, right, 37 you are on, you're on this side, which means I'm likely going to have to take the tube out again. Right, so resistor 37, what was the code? It was D3, so D3, there it is, just above valve 3, which is just above there. I'm not sure if it's that one. It's, yeah, I can't quite get behind there. I can't quite see behind there. I will have to get the tube out again, which gives me an opportunity to test a few other suspect resistors. Well, changing the valve made no difference at all, so I don't think that we are getting anywhere with changing that. In changing that, I don't think we're getting anywhere. Let me grab this. Just want to see if any of the voltages have changed. What was it again? Pin minus 14. See if that measures plus 20. So that means then that that's really high, and then that's really low. Okay. Yeah. But hang on, if that's in the opposite direction, I think I'm going to have to consult the books on this, because there's a piece of the jigsaw that's missing here, if you know what I mean. Right, well, changing that valve has resulted in that going to a minus voltage now. Right, so what does pin 8 then say? Oh, that's a little high, but okay. So it's meant to be 90 volts, 100 VR, which I think is voltage reading or something, but 103. Okay, changing the valve has changed the voltages to where they are, or where they should be, but there is still nothing there apart from that. So let me now learn how to use the zoom control, Aidan. Right, now I want to check these voltages again. So now the cathode of valve, where are we? I've got distracted, there we are. So now the cathode there is measuring 5.5, which is a little bit low, but I'm not going to cry over that. Like, that's fine. 5.5 is close enough to saying that we have got signal of some sort getting in. Okay. Yep, and the minus 14 measured pretty much bang on. And even before swapping the AGC valve, the anode voltages here measured okay. Right, so we cured a fault, but still no difference on the screen. Yeah, so further diagnosis required. Might even be that diode. In fact, it probably will be, but I want to get all the voltages on spec first before I'd go diving into things like that. I think that valve there, which is this one here, I think that's got an internal short, because that was buzzing like crazy a moment or two ago, and the voltage was up at 20 odd, and then it just sort of popped in. It was buzzing worse than that a moment or two ago. I think that valve is on its way out, because let's see if I can mimic it when I switch it off and back on. It's probably not going to do it now. No. Let me just see if I swap these two over, does it make a difference? What's that other 6F23? That is That's got to be valve 4, which is the video IF, I believe, vision IF. So yeah, if I just do a quick swap test and then see what we get from the speaker and the voltage. Okay, right. Not much difference, except that one's got a slightly higher voltage. Okay. I've spent probably the last hour or so chasing my own tail, pretty much. And then I spotted this. That is this capacitor here, 57, which feeds the brightness or cathode voltage to the picture tube. So that is very likely going leaky. Don't feel it being very warm, but yeah, even at minimum brightness, which that specifies 115 volts with the brightness set at minimum, we're getting 150, so there's some stuff from this side that's leaking through it. Okay, that is, it sounds like there's more leaks in it than a government department, to be honest. Just testing that capacitor, and I think this needs to be seen to be believed. 50% voltage loss. 43 microfarads, according to what that measured. 43, 50% voltage loss. That thing is leaky. After changing that, we are getting slightly better. There is a recognisable test card there. That is test card C. Slight change of plan. Okay, I've now decided to not attack the video problem because I think now we need to get the picture stable, like to get that, to diagnose the picture problem. So we need to get that, we need to stop it from losing, from the picture from slipping sideways and losing vertical hold and that sort of thing. So yeah, we need to work our way through these capacitors and I think a couple of these here. So yeah, because that's the frame stage and that's the line stage. And I want to have a look at that one, which is the Hunts there, that's this one here, that's shedded its black, it's black shell, where I'm pointing, there, it's black shell, so that, I think that came off when I was doing the capacitors around the other side. But yeah, we need to get that out. Also, I wonder what that electrolytic there is. I think I've looked at that one. Not tested it, but looked at it in the manual. I think that's part of the line. Sorry, the frame stage as well. Yeah, what does that silver one do? Zoom out. So that is heading the wrong direction. That's the line stage. That is on this side of the line stage. That's other side of the, yeah, what does, where's that? capacitor. Oh, that's really helpful. It's not even marked on there. Turns out that capacitor is this one because it's connected to pin 9, which is the screen of valve 11, which is the sound output valve. Okay, so we don't want to look that. Right, because that's the thing. This is all mixed in. Right, so the frame and sound stage are all mixed in up here. Just opening up the pots here, and it's always lovely and inspirational, isn't it, when the corners, the screw-on corners, start to fall apart. Look, that's always a great sign, isn't it? Just what I always wanted. Right, as you can probably tell from the wet patch, I've squirted these with Servasol. I had to remove this so I could squirt it actually into the carbon track. That one's still a bit stiff, but yeah, because inside these is a sort of, inside these there is a sheet of Paxolin that has a carbon track, and then this has a metal contact on it which wipes along the carbon track, so you change, so it's a variable resistor. So instead of being a fixed value resistor like these, you can change the value of the resistor because there's 3 points to it. One at one end, one at the other end of the resistor, and then there is a third which connects to the middle metal tapping inside it. Right, so let's see if that is at least going to give us any kind of frame lock, line lock I mean, because I'm absolutely sick to death of this being so twitchy. Right, well, it's a little bit better. What do we have in terms of frame hold? Vertical hold. Not much. Okay. Just finishing off for tonight, and in the line stage, that's the flywheel discriminator. So 2 diodes and 2 resistors. Looks similar-ish to a diode bridge. Resistor 87 has gone high. Resistor 88 seems to be okay. I also want to check resistor 89 as well. Resistor 89 is over on the other side. So yeah. Resistor 87, it's supposed to be 120k, it's actually measuring 158 almost. And of course the 680k has gone high. Of course it has. Is it connected to that hunt on there? Well, it's got to be, hasn't it, given the circuit. See that Hunt's capacitor, that 0.1 microfarad down there. It's got to be connected to it. Yeah, it's connected to one side. You probably can't see on here. Where are we? There we are. You really can't see on there, I don't think, but yeah, it's connected to one side of that capacitor. Right, talk about value drift. That capacitor had just allow that to retest for a moment. This capacitor here, 74, which forms part of the line sync pulse integrating, I think, I'm not entirely sure. It measures about 3 microfarads, well, nearly 3.2 microfarads. Yeah, I think we can call that pretty much open circuit. I think that was the changed value just then because I was holding it, and then okay, it's still 1.5 microfarads, 1548. Right, and we are dividing that by 1000 to convert from nanofarads to microfarads. So 154.8, 15.48, 1.548, so that's 1.5 microfarads, not the 0.1 that it's supposed to be, so that's drifted significantly. Well, a few weeks later, because I've just not had the time to do something with the TV, right, and I intend to get back to it very, very soon, because I've been doing something with catching up with capturing the films from Ian's VHS cassettes and sending the files to him. But yeah, I've got it again. And I only had my COVID jab about 6 weeks ago. So this must be a new strain. The jab wasn't designed to mitigate. Either that or my immune system's just crap. Probably the latter, as it usually is. Right, after I dread to think how long, I am back at the Murphy. From what I remember, there's only the line oscillator that needs finishing. Suspected also that there's something might be wrong with the tuner, for which I've got these that I can file down to use as the twiddly things. I've forgotten what you call them, but twiddly thing that goes through that hole to align the tuner, and then just got the soundstage to recap, and I think and a couple here, and I think that will be it as far as the electronics are concerned. As you can see, it still needs a lot of cleaning, and whether I do the cleaning or not will just depend on how I feel when I get to the end of this, really, whether I just sell it on as electronically stored but cosmetically not, or if I sell it on as completely restored, minus the woodwork, because I'm not very good at woodwork. Right, so yeah, just before I grabbed the camera, I decided to test that. That may look like a resistor, but it's not. As you can see, that is a resistor because it's got sort of like, I mean, it's cylindrical, but the edges of it are straighter, whereas that, if you can see, has got sort of rounded edges to it. And that, I've seen those capacitors before, very low value, something like 0.0047 microfarad, 0.0042 or 0.001 or whatever. I've seen those before in other sets from mid to late 50s, and they almost always go bad. This one has, because if I test it, it's measuring 25.6 nanofarads, and if we go on to the circuit diagram, which I am trying to remember where to go, this computer really needs servicing. Where is it? There. That is that capacitor there, C73, which is a integrator or decoupler or something similar. It's either an integrator or a decoupler, and it connects to those two diodes which we had issues with. So I believe it's got to be an integrator because it's part of an oscillator circuit. No, that is a decoupler capacitor. An integrator would have an earth connection on this end of the resistor. I know that there is an earth connection there, but that's because this is a screened cable, hence the dotted line here, the perforated line. So there's only an earth connection there, not on this side of the resistor, because this is the AGC line, which is the bottommost of the two lines here. That's not connected to earth either at that end, which just overlaps with the page that we saw, or at that end, which feeds into this overwind here on the line output transformer. So yeah, let me just get the right page. Is that the one? Yeah. So yeah, that is a decoupler. Right. So that has to be checked, or well, we've already checked it. That has to be taken out and changed. I'll reconnect that resistor because I don't think there was anything wrong with it. I'll retest it though, and I'll change those two diodes. Just a correction, I'm not sure what I was on about earlier with having to have an earth connection at the other end of that resistor, but that capacitor is still a decoupler, right, but it's not measuring the output of the capacitor on both ends. One end of it is just connected to the earth, so yeah, that is a decoupler. So yeah, you know what I said earlier, that is an integrator capacitor. I was right. I'm not really sure what I meant by having to have earth connections at both ends. That is an integrator because the input signal is coming along here from the AGC and it's being fed up to those two diodes. The integrator capacitor is on the output side because it's coming from here through the resistor, then up to the diode. So yeah, that is an integrator capacitor. That's an integrator circuit, alright. Definitely an integrator. As it says here, discrimination is introduced by coupling a sampling voltage at the line oscillator frequency from a small winding on the line output transformer to the junction of the two diodes. Right, so that integrator is for pulses from here, down there, and across there, across there, across there, across there, up through there. That is, and I believe that this is the AGC line. The other side, Vision AGC, goes down there. No, nothing wrong with that resistor. So it's meant to measure 33, it's actually at 37, that's within tolerance, I think. Silver, so is that 5%, so 10% to 33 is 3.3. What? That's not capacitor, come on, wake up. So this is where I show my shoddy maths. 10% is 3.3, so 33. Right, so that's probably going to be actually about 37, so that's, sorry, about 30, hang on, wait a second. Right, so 5% is going to be up to 34.6, or thereabouts. Is silver 5%? Because that would be a strange tolerance for this kind of resistor. I mean, no wonder these diodes tested bad. Look at that. So you can see that that is spinning on its end, and this seems to spring back. So the ends of that are working their way loose. If I grab the one I've just taken out, no doubt it's still bad, but the ends don't feel like they want to turn. That end doesn't, or didn't. Neither does that, nor do they want to spring back. Whenever you're pushing them somewhere, they stay in place. But not so with that. Right, there we are. That's rebuilt. That solder joint actually looks a bit sloppier. It looks a bit sloppier in the viewfinder than it actually is in reality, but whatever. Right, so let's get this old hunk back up on its right side and see if we've made a difference from that wobbly, watery picture that was there before. Let's see if I can do this with one hand. Stuck in one of the grooves on the desk. Right, there we are. Right. So switch on. It's not blown the fuse, so I suppose that's a good sign. Let me just switch that off. Right, valves are lighting up, so there's power. Oh, there's something there. There is something there. No signal though. Why have we got no signal? It's just raster. Honestly though, it does look a lot brighter in the viewfinder than it does in reality. That looks fairly bad in reality. fairly dark. Well, we've got signal. Right, the Aurora was just switched off. Has changing any of those components made a blind bit of difference? No. Well, now I've managed to get it onto a better channel, but then we've got this. Just testing this potentiometer, this, and it's no good. It's one of the, it's the line hold, horizontal hold, and that was really touchy to the, it was really touchy. I don't know if it's what was causing all the waviness in the picture, but it was really touchy. It shouldn't be that sensitive to, yeah, see, before, if you noticed, it was showing a capacitor. That's definitely not a capacitor. Now it's showing no unknown or damaged part on the, between one end and the middle pin, which is the wiper, the output of whatever out. It's the output of the voltage when you've turned it, when you turn it. So now it seems to think it's a capacitor. Yeah, I'm not even sure how that's possible. It's in between pins 2 and 3. I know that there is a green one in there, which is for pin 2, but that's not even connected. And for pins 1 and 3, it seems to think it's a resistor. I've just turned it slightly, and if I retest it, now it thinks it's a capacitor. Yeah, that is batshit. That is going completely crazy. So, right, and this type of potentiometer can be quite hard to get when new, I think. I'll need to have a look around for any large surface ones, surface mount ones. But that's a 25k potentiometer. This is the closest I could get from just my store's, my testing thing, which is 47k. I'll need to add a third wire to it. So let's see if this manages to sort it. Now that I've just temporarily tacked in that 47k, look at that. That's not just waving, that's doing the Mexican wave, the TV Mexican wave. Look at that. It's locked. Now I need to work out what this crap is. Update since yesterday. First of all, my Variac has given up the ghost because one of the brushes on it, one of the coils on it started to come apart. I moved it and then it snapped one of the brushes off inside the Variac. We are currently troubleshooting I'm not really sure whether it's a tuner issue now, whether it's an actual fault in the tuner, right, because all the voltage is measured okay, or whether it's a problem with ripple, with hum, getting from these. I will be honest, I'll hold my hands up. I did try twiddling this, and it seems to be locked solid. That is the fine tuning control. Murphy was so confident of their tuner design, tuner stability, that they didn't provide a user fine-tuning control on the top, so there's no twiddling fine-tuning control. That is the fine-tuning control. You tune it once and then it's set, and it has them on each of the coils for the tuner biscuits, or wafers, whatever you call them. But chasing up this ripple problem, I've discovered something that has been staring me right in the face and I've not even noticed it, which is par for the course for me, to be honest. One of these shouldn't be there, because according to the manual, there's only one. I need to turn it upside down. There's only, oh sorry, my camera seems to automatically, when I'm looking at it in the viewfinder, it seems to automatically correct the way round in which things are. I don't know if it does it for you, but it does it in the viewfinder. Anyway, so this here, 100 microfarad, 200 microfarad. According to the manual, there was only one 100 microfarad capacitor and one 200 microfarad capacitor, which are both actually encased in this. It's these cans, they're multiple capacitors in one package. So why does it have another? Let me just move that. Why does it have another 100 microfarad and 200 microfarad? So my guess is, and this was a really common problem back in the 60s, is that this gave up, or started to give up, and started to produce a ripple in the picture where there's a variation in the size of the picture that runs slowly down, or sometimes slowly up. I think it's actually slowly up the picture. A certain amount of ripple, AC ripple, is normal for a TV, up to a certain amount, because if you're looking at it on, or was normal for the time, but if you're looking at a picture, just a still picture like a test card, you would notice a little bit. That was normal, because you wouldn't notice it on moving pictures really. But it's when it becomes noticeable on moving pictures that these started to give up, and it became more noticeable when broadcasters began to stabilize. There were different methods of digitally stabilizing their pictures, or even, well, electronically. I'm not sure digitally or not. Sorry, just sorting out my pocket. There were ways back in the 60s where they were able to make the pictures taken by cameras and transmitted to be more stable, right, so that you didn't have to adjust the vertical hold so often, that sort of thing. But making it more stable meant that ripple from these became more visible on moving pictures after only a couple of years of the TV being used, because this is almost directly connected to mains current. The materials that they used to make these electrolytic capacitors began to suffer over a couple of years, and then once TV broadcasters began to stabilize their images more, that's when the damage that had been done to these over a couple of years' use became more obvious in the form of ripple. So these were a very common problem in the 60s. So I think that is why this is installed. I'm not really sure why the engineer didn't take this out. It was probably a rush job, and in order to get it out of this model, really to have any space to do it, even in the service position, you have to remove the tube and unplug all sorts of wires and that sort of thing, which is really quite time consuming. Probably great if it's going to be a Monday morning job, but if it's going to be last thing on Friday evening, or last thing Saturday lunchtime, or last thing Christmas Eve, and you've got a customer who desperately wants their TV for the weekend or for Christmas, then you're going to resort to this kind of work, where you would leave that in place and you'd wire that in as a replacement. But I think what the engineer either forgot to do or was too lazy to do, probably 50-50, is disconnect the original. You don't need, in order to remove that, in order to remove the entire thing, ideally you'd need to get the whole tube out, but which, as I said, is time consuming. But just to cut those cables, come on, you could easily get some wire cutters or scissors from one side, down one side. You know, if this had been on its the right way up, you could easily get them just in that side or in this side, probably this side more likely because it's nearer, and just cut those wires. There's no excuse. I don't think there's any excuse for that, for leaving those in. I better be careful because there's probably still charge on it, but there's no excuse for that. Right, so I think it's going to be more important then if we tackle this, because if there's AC ripple that's causing the picture to wave side to side, then there's also going to be ripple getting into this, which is going to make it not work as it should. It's that makes the picture, that's supposed to tune the picture in properly. It doesn't look as though it's tuned in properly. That could be because this fault here is putting extra AC alternating current onto this where it shouldn't exist at all, because these are part of the circuit along with this diode that's down here somewhere, yeah, because I got the tuner cover off, along with the diode on here. Where is it? There. Along with the diode there. That diode and what's supposed to be just one of these capacitors forms a circuit where it filters out AC. One of these has got to come out, in fact both of them I would say, because what I don't want to do is remove one and then risk the other one going even further, because these can actually, because the chemical inside these can start to become conductive, these can actually get warm to the point where they get hot and they can actually go zoom and disappear off in all directions, which is very, very frightening. I've not had it happen to myself before, but I've seen it happen to others occasionally. So yeah, one way is, I suppose I could completely remove both. Half of me is minded, in regards to this one, half of me is minded just to cut the cables and leave it in place. The other half of me is inclined to completely remove the tube and then remove both. That one's got to come out anyway. That one can easily come out without removing the tube, but that one, yeah, I'm in two minds about that one, whether to just cut the cables or remove the tube and then take that out completely. Probably what I want to do is the former, but probably what I should do by rights is the latter. Yeah, lots of fun and games with this. This has definitely been, it's had a long life in the past. Definitely not original. Definitely not. That, don't know if you can see that, but that has been added on because it's got a nut there to hold the screw in place. And also, speaking of screws, that one is rusty as hell, and that's the original. That one is the Lancia Beta or whatever of screws. That one, even though it's on its way, doesn't look quite as bad, which implies that that screw is newer. I know that the collar holding it to the capacitor is rusty. That could be many years old, because the engineer who did this could have taken that from a scrap set. That screw would have been new at the time. That one would have been new at the time some years earlier, before that one was installed. So yeah, okay. And yet more example of stellar work as well on it. Those two terminals, those two wiring terminals are joined together. That's where I've got my meter hooked up. I know that there is another tag, if I can just get it down here. There's 3 tags, one of them and 2 of them are joined together. So those 2 that are joined together are going to be the outputs for 100 and 200 microfarads. The other one is just an earth connection. On there they are separate. They're not joined together by a piece of wire. And on here it's because they have to be separate, or rather ideally should be separate. One to provide smoothing to the voltage selector, the other to provide smoothing to the HT rail. If they are both connected together, as in that, then that means that there's either going to be all the smoothing here, which means that there's going to be no smoothing there, or all the smoothing is going to be there and there's no smoothing here. And I think that all the smoothing is on this, because this is connected by this wire to the audio transformer. Now on the audio page, which in true Murphy style is separate to the rest of the circuits in the manual, the audio stage, it's connected to this transformer, and the top of that transformer, of course, is the HT rail. So someone has connected this up to there instead. So in fact, maybe, you know, there was 300 microfarads of smoothing that needed here as well, but why would you need that? Why would you need that? Maybe a fault in the audio stage, but why would you need 300 when? So yeah, that could be a possibility in case there was extra smoothing needed here, but with the amount needed, 200 plus 100, which equals 300, that's a bit of a coincidence, given that that's 200 plus 100 as well. If the tuner fault, so if what I thought originally was a tuner fault is down to this, then is down to these, then just taking those out and replacing them should do us. And then I've just got to readjust that. Oh, and now while there is sound, right, so clicks and that sort of thing coming from the tuner when I change the channel, there's no actual program sound coming through at all, no tone from the test card at all, so yeah. And one more example of this capacitor not being original, that is the other end of the earth lead. You can't tell me that soldering is original, that's factory. That's not factory. So there would have been a tag there that already had this black wire over to it, and someone else has just added that extra wire on to accommodate the earth connection for this capacitor. So is that an RS? RF? Radio spares, I believe. Oh yeah. RS with the little man in the middle, the service engineer wearing his cap, running or jumping or whatever. Kind of like a 60s reversal of the old BT logo from the 90s. Update. I think it's not the night after the last clip, it's the night after the last clip. We've made a bit of a discovery. I'm using the Royal we. It's 8:40 and it's already getting to that stage of the night. So a bit of a discovery of yesterday. The RF, the tuning was all screwed up, and that was with the set on its side, and also there was loads and loads of hum. That was with the set up on its right hand side. Today I've got the set upright. Now first of all, you'll notice that the tuning is probably very clear. I really don't understand that. That's unless with the set on its side the tuner was picking up some interference, because there's going to be loads of switch mode power supplies around here chucking out crap, or maybe the Wi-Fi, maybe the Wi-Fi is interfering with it as well. But with the set straight up as it should be, upright, the perfect tuning, but you'll see that the picture is waving about, so we've still got loads of hum. I wish I'd caught this on camera. When I switched it on tonight with it upright, this was not waving. This was not waving at all. And then after a few minutes, as I was actually staring at the screen in bemusement, it just started doing this. It wasn't like a gradual thing, it just clicked and started doing this. So last night I asked the opinion. I shot a short video, don't know if I'll be able to find it, but I asked the opinion of the people, the great guys on the UK Vintage Television Collectors Facebook group, and a few of them, well, they all agreed that it was hum. Because originally what I wanted to do was I wanted to get rid of the hum in case the hum was also causing the tuning issue, because this basically is AC getting to where it shouldn't be. So if it's getting on there, who knows where else it was getting into within the set and causing other interference. That was my theory. So yeah, I asked the guys on there, and they all generally agreed that the hum needed to be dealt with first, and they gave me a few suggestions. Of course, what can happen most of all is the most likely cause of that can either be down to inadequate smoothing. Now I've tidied up the capacitors around there. I've put in a known good replacement and taken out the both the original and the substitute from the 60s. That made no difference. I've also started changing some of the valves, because what can happen is there can be a conductive path that develops between the heater, which just carries AC, and the cathode, which is what is supposed to emit DC, and that can cause that. Also, I think Chris suggested, see now, it's much less worse than it was, so now it's gradually going. Chris Field, I think, as well, I think is his surname, sure of that. He also suggested that some of the decoupling capacitors that are in the heater chain can cause that. Well, at the time I didn't disagree. I think the fact that this just was working and then it just started rippling, I think that proves it's much more likely to be a valve. I've never heard of a capacitor, well, I don't doubt it's not impossible, but I've never ever heard of a capacitor just being okay 1 minute and then just suddenly going faulty or going open circuit. So it's not 100% impossible, but I think given the fact that that can't decide whether it's coming or going, it's unlikely now. Also, what I've noticed as well is when this TV is starting up from cold, before this waviness, before this hum develops, the picture is quite hard to control. Sometimes sometimes the brightness will be much lower, and you can't even adjust it with the brightness or contrast. It just completely ignores any attempt to change the brightness. So I have read online that something like that might be symptoms of a heater cathode short actually within the tube itself. But usually when I've seen that as well, you get streaking from the right hand sides of stuff. For example, where solid black here goes to white there, but there's no streaking. I mean, there's a little bit of ringing there, but there's no actual streaking. You can see it's more or less a clean cut. Just moving the set accidentally. It's more or less a clean cut between black and white there. So I don't know what I'm going to do. First of all is test the tube again. I think I did it at the start of this restoration. I can't remember for certain. Even if I did, and even if it tested okay then, I think it's not entirely impossible, for it to have tested okay then, and then repeated use giving it an issue. Not completely impossible. I mean, that's what used to happen. Electronic gadgets, the point where they actually break down is when a surge of current is passed through them, either at switch on or switch off. It's very, very rare, not impossible, because it has happened in the past, obviously, but it's very rare for something to just break down in the middle of using it. I don't think there's any more point carrying on with this, because when I was connecting that up just to retest the tube, look, these are loose. I think the word is shit.